Welcome to AI Frontiers, where we explore the discoveries that are reshaping artificial intelligence. Today we're diving into the latest advances in computational linguistics research, focusing on breaking language barriers through reasoning and cultural understanding. We'll explore breakthrough discoveries from October 22, 2025, that challenge everything we think we know about multilingual AI systems, efficiency in language model training, and medical AI applications in underrepresented languages. Picture this. A doctor in Tehran is consulting an AI assistant about a complex medical case, asking questions in Persian and receiving thoughtful, reasoned responses that could help save a life. Meanwhile, in Dhaka, a researcher is testing whether an AI system truly understands Bengali cultural nuances, only to discover that despite its impressive general knowledge, it struggles with the most basic cultural references that any local child would know. And in a lab somewhere, an AI agent is drowning in a sea of thousands of available tools, unable to pick the right one for a simple task, because it's overwhelmed by choice. These scenarios aren't science fiction. They're the cutting-edge realities that 13 groundbreaking research papers are working to solve. Computational linguistics is fundamentally reshaping how humans and AI systems interact, moving us toward true understanding rather than mere word processing. Computational linguistics sits at the fascinating intersection where the precision of algorithms meets the beautiful complexity of human language. This field has become the backbone of the language technologies that millions interact with daily, from translation apps to conversational AI assistants. What makes this moment particularly exciting is that we're witnessing a fundamental shift in how researchers approach these challenges. The field is moving beyond the bigger is always better mentality that dominated the early days of large language models. Instead, we're seeing a renaissance of clever, targeted approaches that achieve remarkable results with fewer resources, smarter training methods, and deeper understanding of what makes language truly work. Today's researchers aren't just computer scientists. They're linguists, cognitive scientists, cultural anthropologists, and philosophers, all rolled into one, tackling questions that go to the heart of what it means to communicate and understand. Think of computational linguistics as the master translator's workshop of the AI world. Just as a skilled translator doesn't simply convert words from one language to another, but captures meaning, context, cultural nuances, and even the speaker's intent, computational linguistics researchers are building AI systems that don't just process text, but truly comprehend the layers of meaning embedded in human language. This field represents more than word conversion. It's about capturing meaning and intent. Researchers working in this space function as linguists, scientists, and philosophers simultaneously, creating the backbone of daily language technologies we've come to rely on. The current renaissance focuses on clever, targeted approaches that prioritize understanding over brute computational force. The first major theme driving the field forward is reasoning enhancement, teaching AI systems to think through problems step by step, much like a detective carefully examining clues to solve a mystery. Instead of simply pattern matching, these systems are learning to engage in genuine logical reasoning, breaking down complex problems into manageable pieces and working through them systematically. The work by Ghasabi and colleagues demonstrates how reasoning-focused training can dramatically outperform traditional approaches that rely on raw data volume. This represents a fundamental shift from memorization to genuine problem-solving capabilities. The implications extend far beyond individual applications, suggesting that we can build AI systems that truly understand, rather than simply recognize patterns. The second theme focuses on cultural and linguistic diversity, addressing one of AI's most glaring blind spots. Imagine trying to navigate a foreign country with a map that only shows major highways but misses all the local roads, cultural landmarks, and neighborhood secrets that locals know by heart. That's essentially what happens when AI systems trained primarily on English text encounter other languages and cultures. Researchers are now building bridges across these cultural divides, ensuring that AI systems can serve people regardless of their linguistic or cultural background. The fascinating discovery is that when provided with cultural context, AI performance improves dramatically across all tested models. This suggests the issue isn't fundamental model limitations but rather training data and architectural choices that can be addressed. The goal is democratizing AI for underrepresented communities worldwide. Our third theme revolves around efficiency and optimization, the art of doing more with less. Think of it like a master chef who can create a five-star meal with just a handful of ingredients, while an amateur might need a fully stocked pantry to make something half as good. Researchers are discovering that strategic, targeted trading approaches often outperform brute force scaling, leading to more sustainable and accessible AI development. The most striking example comes from Persian medical language models, where scientists demonstrated that a model trained on just 4.5 million carefully curated tokens of reasoning data significantly outperformed a predecessor trained on 57 million tokens of general data. This fundamentally challenges the prevailing bigger is better philosophy and suggests that quality trumps quantity in data selection. These approaches enable more sustainable and accessible development paths for AI systems. The breakthrough discoveries emerging from this research are nothing short of revolutionary. Persian medical models prove that smart training beats data volume, with reasoning-focused approaches achieving superior performance using 1/10 the training data. Cultural knowledge understanding improves dramatically when systems are provided with appropriate context. Toolscope, a new system for optimizing AI tool selection, enhances accuracy by up to 38.6% by intelligently organizing and merging redundant tools. Memory-augmented learning systems achieve performance improvements of up to 24.8% by incorporating both specific experiences and general principles derived from feedback. Perhaps most intriguingly, new word-by-word parsing algorithms match human language processing patterns while maintaining computational efficiency. These findings collectively challenge our fundamental assumptions about how AI systems should be built and trained. Today's featured research represents a paradigm shift that could fundamentally change how we approach specialized AI development. The work by Ghasabi and colleagues on revolutionizing medical language models through reasoning enhancement tackles the double challenge of language underrepresentation and specialized domain knowledge. Instead of following conventional wisdom to collect more data, the team took a radically different approach, using reinforcement learning with AI feedback, combined with direct preference optimization. Their focus on Persian medical question answering proves that strategic, reasoning-focused training can outperform traditional large-scale data approaches. This research provides compelling evidence for resource-constrained environments and underrepresented languages, where large-scale data collection is impractical. The methodology offers a path toward more efficient and effective language model development, with profound implications for democratizing AI capabilities globally. The methodology behind this breakthrough is elegant in its simplicity, yet sophisticated in execution. The researchers created a dataset containing 2 million tokens of preferred answers and 2.5 million tokens of rejected responses, totaling 4.5 million tokens of reasoning-focused training data. Instead of trying to memorize every possible medical fact, they taught their AI system how to think through medical problems step by step, like training a medical student to reason through diagnoses rather than just memorize textbook answers. The training process utilized direct preference optimization, allowing the model to learn directly from preference pairs without requiring a separate reward model. This approach proved particularly effective for reasoning tasks because it enabled the model to internalize the logical processes underlying correct medical reasoning rather than simply memorizing question-answer patterns. Cultural and linguistic appropriateness was ensured throughout the process. The results were nothing short of revolutionary. The reasoning-enhanced model significantly outperformed its predecessor, which had been trained on approximately 57 million tokens of general data. A model trained on less than 1/10 the data achieved superior performance simply because that training was strategically focused on reasoning rather than raw information absorption. This provides compelling evidence that targeted, reasoning-focused training can be more effective than brute force scaling approaches. The significance extends far beyond Persian medical models, with profound implications for resource-constrained environments, underrepresented languages, and specialized domains. The methodology offers a path toward more efficient and effective language model development, particularly relevant as the field grapples with the environmental and computational costs of ever larger models. This challenges our fundamental scaling assumptions about AI development. Looking toward the future, we're approaching a world where language barriers dissolve, not just in terms of translation, but in true cultural understanding. AI systems will bridge worldviews, not just convert words, helping people from different cultures genuinely understand each other's perspectives and ways of thinking. We're moving toward AI systems that can reason through complex problems with human-like sophistication while maintaining the speed and consistency that only machines can provide. These systems will become true collaborative partners, understanding not just what we're asking, but why we're asking it, adapting responses to our cultural context, expertise level, and specific needs. The efficiency breakthroughs suggest a future where powerful AI capabilities become accessible to researchers, organizations, and communities that previously couldn't afford massive computational resources. Perhaps most excitingly, we're approaching AI systems that can learn and adapt continuously, building on experiences like humans do, rather than requiring complete retraining for every new task. The 13 papers we've explored today represent more than just technical advances. They're stepping stones toward AI systems that can serve as genuine partners in human endeavors. We're witnessing the emergence of AI that doesn't just process language but begins to truly understand it, breaking down barriers of language and culture while enhancing our ability to reason, learn, and solve complex problems together. From AI systems that can reason through complex medical problems in underrepresented languages, to tools that help agents navigate vast collections of resources, from models that understand cultural nuances to systems that learn from experience. We're seeing remarkable progress. But here's the thing about frontiers. They're only meaningful if people explore them. These discoveries need curious minds to build upon them, creative thinkers to find new applications, and diverse voices to ensure they serve everyone. Your perspective could drive the next breakthrough in this rapidly evolving field. This research summary was synthesized using GPT Anthropic CLAUDE-SONNET-4-2 DO250514 for content analysis and synthesis. TTS synthesis was powered by DeepRAM technology to ensure clear audio delivery. Image generation utilized OpenEye systems for visual content creation. All synthesized content underwent human expert review to ensure accuracy and completeness. While every effort was made to accurately represent the research findings, potential oversights are acknowledged and original references are provided for verification. The synthesis process combines automated analysis with human oversight to deliver accessible yet technically accurate content. This approach enables rapid processing of complex research while maintaining scientific rigor and accessibility for diverse audiences. Thank you for joining us on AI Frontiers, your gateway to cutting-edge research. Subscribe for weekly research syntheses and explore the frontiers of artificial intelligence with our community of researchers and enthusiasts. Share your thoughts and research insights as we collectively push the boundaries of what's possible in AI development. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprint-server.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprint-server.org.